fifth grade, we are out here for your creek visit day. We are out here at Eagle Creek, and as we're out here, you'll notice that Mr. Wall and I might shiver a little bit because it is really cold. In fact, I even brought my Santa shirt because it mimics how cold it is today. But we didn't want you guys to miss out on your creek visit, so we have a lot of things that we're going to be showing you today as we do a lot of the chemistry, the things in the creek to be able to better understand what's happening that's not able to be seen by doing a couple of different tests like dissolved oxygen, also measuring the orthophosphate levels, and to be able to see again how healthy this creek is by looking through the lens as a scientist using the chemistry of the water to better understand it. So we're gonna get in and we're gonna make sure that we get all that stuff done today. So let's have some fun. All right, so some of the macroinvertebrates that we're finding right now, kind of like this guy in my hand. This is a mayfly, and again, these macroinvertebrates are great indicators as to how clean the water is. So these guys, I believe, are in level 2, along with the right-handed snail shell and the damselfly. They're level 2, which means that they're moderately intolerant, which means that when we talk about how clean the water is, they will only live in water that's fairly clean. Now, it's not like picture perfect clean, but in terms of how clean this water is, it's fairly clean. And so these guys can live in that type of water. If this water was like sewage water or really standing still type of water that didn't flow, didn't have much oxygen in it, these guys wouldn't be able to survive. So the fact that we can find them in the water means, again, that this water's got to be clean. It's a good indicator of the type of health of this water. All right, ladies and gents, you guys are very fortunate because even though it's really cold, Mr. Wall and I found my most favorite macroinvertebrate of all time. This is a caddisfly nymph. Now, you can start to see this guy's head is actually starting to poke out a little bit as he's curious. This guy actually makes his home out of debris in the creek. So depending on what type of debris, what kind of bottom or substrate this creek has, is the type of, there he is, the type of shell that he will create. Now, because this debris, or the bottom, the substrate here is made of a lot of stick and muck and dead leaves, he actually is making his home out of that type of resources. And then what he'll do, because his body is so soft, is he'll create a shell, he'll piece the parts together, and then he'll use that shell as a mobile home, that whenever he needs to hide from another predator, he hides inside of it, and then he's able to also bring his home and his protection along with him. But other types of caddisfly, depending on different types of streams, some will make theirs completely out of rock, but this guy, again, super cool, one of my favorites, just because it, again, reminds you a lot like a turtle. You want to make that connection where the turtle has a really soft body, and so that shell protects it from predators and becomes that home that it's able to bring with it. And that's the exact same way that this guy will make his home as he spends majority of his life in the water. So really cool, fascinating find, especially on a cold day. This is awesome. This test is called a test of dissolved oxygen. Now you might have been wondering how things like fish and macroinvertebrates survive in the water. If we go down into the water and we go underneath, we have to hold our breath.
there's no way we're going to breathe underwater. We just don't have the requirements to be able to do that. But fish, they have gills on the side of their head, and they're able to pull oxygen out of the water. So whether you believe it or not, there is actually oxygen mixed in with the water. And the way it gets mixed in is through the air as it tumbles over rocks and things like that. As water is moving, it pulls in some of that oxygen into it. Now, there's a lot of variables that affect how much oxygen a stream can actually hold. One of those variables is temperature. And so in order to do an adequate dissolved oxygen test, the very first thing we have to do is find out what the temperature of the stream is. So I'll just take this thermometer. I'm going to go ahead and dip it into the stream. I don't want to get the surface level temperature though, but I don't also want to be dragging it on the bottom. So I'm going to put it about halfway down and just hold it under there for about 15-20 seconds or so to be able to get an accurate reading. Now this thermometer does measure in Celsius as opposed to Fahrenheit, so you would have to do a small conversion if you wanted to convert it over to Fahrenheit. Now today we're looking at about around 15 degrees Celsius, somewhere in there, maybe 14, even 13 maybe. So what we'll do is we can use that temperature to help us solve the dissolved oxygen. I'll be right back with dissolved oxygen, the test. So this is a pretty interesting test, boys and girls. What you'll do is you'll get a sample of stream water, and you want to fill it up to about the 25 milliliter mark up here right at the top line. When you do that, you're going to want to go under the water and get a good sample again, like I did with the temperature. I'm going to pour some out until I get it right about 25 milliliters. At the bottom of this very special vial, there are some holes in here that are perfect for these ampules. So these ampules that are inside this box are glass, and they're meant to shatter, and there's a liquid inside here that will actually come out. And so when you're ready to do this test, what you do is you take the ampule, you put it into there, take the tip, and put it down into one of these holes. You're actually going to break it, and you'll hear an audible snap. Okay, at this point, I can go ahead, and you're going to see that's turning instantly blue. I can go ahead and take it out of the sample of water and invert it a number of times. I usually like to do this 10 or 15 times just to make sure that I'm going to get an accurate reading. And finally, I'll compare that to the nearest coloration on this chart. And you just really have to use your judgment, boys and girls, but I'm going to put it beside every one, and I want you to try to see if you can figure out which one it is. How many parts per million dissolved oxygen. Of course, this won't give you the final answer. You would still have to use a mathematical formula to figure out, using temperature, to figure out how much oxygen is in the water.
All right, so another test that we do while out at the creek, another chemical test, is that we measure what we call the orthophosphate levels. Now, the orthophosphate levels is talking a lot about, and I know it's kind of silly, talking mainly about the poo or the decomposition in the water. So when we think about runoff that comes from farm fields, or when we think about even some sewage pipes, point sources of pollutants that would be dumping into the water, that's where we can get a lot of high levels of orthophosphate. Now, we've tested Eagle Creek for many years, and even testing it today, we would yield a result that's going to be very similar to what we've seen before, especially because we had rain yesterday and even a little bit today, where all that oxygen in that is being put into the water, so we're having high levels of dissolved oxygen, and the fact that it's the beginning of springtime, we're not going to see high levels of orthophosphate. But what we would see if we did this test is we're going to see a number that's actually going to dip below 1 on the scale, because we would actually need to use the chemetrics tube to be able to see even orthophosphate levels that are less than 1 parts per million. And so when we do that test, it's very similar to the dissolved oxygen, where we use the ampule, we get a sampling of the water, we break the ampule in that sample of water, we allow it to invert, to move that bubble all the way up and down, to be able to mix it, and then we compare it on this color chart. And like Mr. Wall said, it's very subjective to where you believe it matches. But as scientists, that's why we take these tests to be able to look at those changes over time to see, are there any differences in our results? Now, another test that we do while out here is a pH sample, and I'm going to use this. It's just a regular tube that you can use for plants to be able to measure kind of the pH levels. But what we're going to do with this is we're going to take this little tab that has two different color charts on it, and what I'm going to do is I'm going to dip it into the water, and I'm going to swish it around to allow the colors to get an accurate reading of my water. And when we talk about pH, so when we're referring to pH levels, we're talking about how acidic or how basic the water is. So when you think about things that are acidic, like lemons or limes that would kind of break down the enamel on your teeth, or you think of things that are really basic, things like cleaners and stuff that would be able to break down some of the nutrients that are, or kind of some of the organic things on stuff. When we think about pH levels in the water, we would want it to be fairly neutral. When you think about neutral in terms of the pH scale, it's typically like what you think about your spit. Your spit measures at about a 7. So if you kind of get a spit wad in your mouth, yeah, it's about a 7 on the pH scale. So what we're looking for is water that's fairly neutral, fairly similar to the spit in your mouth. And so what we do with this matching sheet, we hold it up and we're looking for the colors that would best match together. Not one color, but both of them together. And about where I find the best fit match is about my reading on this pH scale. So as I go through, what I notice is probably similar to you, that our range is right in that healthy range where our water is pretty neutral, about at a 7.5 on the pH scale. So again, pH, when we see it at that neutral, that regular range, kind of that what we would expect, that neutral, that means that, again, the water is not too acidic, not too basic, which means that it's perfect for life. All right, so ladies and gentlemen, why we collect all the different macroinvertebrates that we find in the creeks and in these bodies of water is because they're indicators for us as to how clean or how unclean the water is. So we have different levels of macroinvertebrates that are on these different categories of water quality. The first category is your intolerant group. All right, these would be macroinvertebrates that you find kind of like the caddisfly larvae that we found in the creek today, as well as then others like the mayfly, and others even like the right-handed snail. But those guys in that group are indicators to us that if we can find them in the water, that the water has to be extremely clean. Now, we're not talking like pool water clean where there's chlorine or chemicals in it, but when we talk about a natural body of water, this is as clean as the water would generally be because it's moving, there's lots of oxygen, it's a good temperature, there's good levels of phosphates, there's not a whole lot of decomposition. So when we talk about, again, group 1 guys, those macroinvertebrates are going to be ones that we find in really clean water. Then as we get further down the list, you go all the way to the other end where you have your group 4, those who are very intolerant. So 5th grade, a field trip that we typically make is out to Pisgah Marsh, where we go up in North Webster and we look at a body of water that's very stagnant. It's not moving, so the oxygen levels are really low. We typically find a lot of group 4 macroinvertebrates in there, as well as some in group 3 and 2, but a lot of group 4, because those guys like water that can typically be very pollutant, and they're very tolerant of that. So what that means is that if there's not a lot of oxygen or there's a lot of other chemicals, even potentially even sewage water, you would find group 4 guys in that type of water that can survive and live there. Now, if you go out into a body of water and you find a little bit of group 2, group 3, and group 4, then you go all the way up to the highest level of what you found in that body of water. That tells you as to kind of the level of the cleanliness of the water. So if you find group 2, 3, and 4 all in one body of water, then you can know that the group 2 is a good indicator as to how high, how clean that water is. But if you can only find group 3 and group 4, then again, you go up to that level like group 3 to be able to indicate to you how healthy and clean that water is.